Hello and welcome to Amit's Tech Sessions. My name is Amit and I am a software architect. In this session, I'll talk about distributed systems and a few associated architecture patterns which are used commonly with distributed systems. I would also cover why AWS is an amazing platform for building and hosting distributed systems. And finally, I will walk through an AWS reference architecture. So first, let's understand what is a distributed system. A distributed system is a system which is collection of multiple compute systems which work together to solve a common problem. Distributed systems generally span across multiple physical locations to form a running application. Since distributed systems span across multiple locations, they provide large, powerful resources which can help deal with the complex challenges. There are various benefits of distributed systems. Scalability is one of them. Distributed systems are scalable by design. They can add additional nodes whenever there's demand increase. In addition to nodes, they can also increase computational power within the same node. Availability is another benefit. Since distributed systems span across multiple locations, they provide high availability. Since the system is composed of multiple independent nodes, the failure of one or a few nodes does not halt the entire system. Other nodes in that network can continue their operations, which ensures that the system is running fully functional at all times. Distributed systems are also very highly efficient. They divide a large task into smaller subtasks and then process them concurrently. So this helps in significantly reducing the time which is required to complete the task. Transparency is also one of the key feature or advantage of distributed systems. A distributed system is built of multiple nodes and there is complexity behind its architecture. However, that complexity is never visible to the end user. So this transparency simplifies the user interface and makes the system easier to use. As we discussed earlier, if you have some part of your system down and system is still able to function, this makes those systems fault tolerant and it also provides a great sense of reliability. And one last benefit is reduced latency. So if a particular node is located close to the user, then distributed systems would ensure that the user is fetching the data from the node which is closer to the user, which actually helps in improving the latency of the system. There are different type of architecture patterns which are used in distributed systems. I'll discuss some of them here. The first one is client-server pattern. In client-server pattern, the system is divided into two type of nodes, clients and servers. Clients generally request the services and servers will provide the services back to the client. That's it, very simple. Second type of architecture pattern is a three-tier architecture. In this type of architecture, system is divided into three different layers: presentation layer, application layer, and data layer. The presentation layer handles the user interface side of things. The application layer processes the business logic, and the data layer manages the database. Another type of pattern which is used in distributed systems is called pub/sub pattern or publisher-subscriber pattern. In pub/sub pattern, a publisher sends a message or an event to one or many consumers. Pub/sub pattern allows you to broadcast the messages and send a copy to each of the consumer or subscriber, whoever is interested in that particular message. Another pattern which is widely used is service-oriented architecture. Service-oriented architecture is a pattern or style where you divide your application or system into multiple components or services to achieve a business goal. These services work as components which helps to achieve the shared goals. One other pattern is event-driven architecture. In event-driven architecture, one or more producers send the events to an event broker, and then interested parties can subscribe to those specific events and perform any data processing based on those events. One other pattern is microservices architecture. In microservices architecture, the application or the system is decomposed into independently deployable small services which altogether form that distributed system. So now let's understand why you should choose AWS for building and hosting distributed systems. AWS is a great platform to build the distributed systems. I'm not just saying this, but I'll provide the reasoning why it is a great platform. And first of all, AWS itself is a distributed system. AWS provides regions which are separate geographical locations miles away from each other, and these regions provide the redundancy for any system. AWS provides support and services to deploy different architecture patterns. For example, if you want to deploy microservices on AWS, there are various options available to deploy your microservices. AWS provides a service called auto-scaling, which allows you to scale up and down the nodes based on the demand of your application or the system. AWS is a highly available cloud platform, and most of its services have 99.99% availability or more. AWS does have the availability zones within a region, and these availability zones ensure to provide the high availability to your application or distributed system. Tracing is very important in distributed systems because in distributed systems, the communication happens across the locations and it becomes hard to trace the requests and the responses. AWS provides a service called X-Ray, which can help find out and build those traces very easily and in an efficient manner. AWS does provide a well-architected framework which allows you to assess your system or application as per the pillars of well-architected framework. Well-architected framework has 6 pillars: performance efficiency, operational excellence, security, reliability, cost optimization, and sustainability. By using well-architected framework, you can assess your distributed system against all the best practices of AWS well-architected pillars. Now, this is a sample reference architecture of a distributed order management system on AWS. So on the left, there are enterprise applications which feed the data into OMS. And this data includes the facility attribute data, such as store data, warehouse data. This data also includes product data and inventory data. E-commerce data is also sent to OMS for allocation and release. The integration layer in the middle consists of multiple AWS services that support the file transfer for external file feeds, APIs, event-driven patterns, and streaming for inventory and master data. Then there is ETL or extract, transform, and load layer that consists of AWS Lambda functions that consume and publish data to Amazon Kinesis data streams and also Amazon Event Bridge. There is also AWS Glue, which loads and transforms the data for batch transactions. The data layer consists of Amazon Aurora for transactional data and Amazon DynamoDB, which serves the requests at low latency. This system OMS, Order Management System, exposes a graphical user interface that associates will use to create and modify the orders, which in turn calls the necessary APIs from the API layer. And this API layer consists of the Lambda functions, the presentation layer of OMS or Order Management System, and other applications such as e-commerce, front-end, and customer care invoke these Lambda functions. The allocation engine consists of Lambda functions and AWS step functions. These services execute the optimal allocation logic and then publish the e-commerce orders to the event bridge and then identify the appropriate facility to fulfill the order. Event bridge then sends the order to the fulfillment applications, associates pick and pack the items, and then sends the shipment confirmation to OMS. And data moved by the integration layer is then sent to the analytics layer, and Amazon Redshift generates the insights on order processing efficiency. So this was a high-level sample reference architecture. If you want to build a distributed order management system, this is a reference architecture for you to take a reference from. That's all I have for this video. I hope this was useful. If you would like to connect with me on LinkedIn or Medium, there are QR codes up on the screen. Thank you very much. I'll see you in next session.